I'm magically in a horn. It's fine. Okay, so let's go ahead and knock out these two lessons. Okay, chapter 11. All right. So we are going to knock out these two lessons today. So how do AP exam scores compare? Yay! We're going to find that out. So the AP Stats teacher from East Kentwood wondered if her students' AP exam scores from the previous year were better than the scores from the rival high school to the north. Boo. She took a random sample of 10 of her students from last year and found a mean AP score of 3.8. So identify the population parameter, sample, and statistics. So what's the population? All AP Stats students. Don't write that down. At East Kentwood, right? All the kiddos in East Kentwood, and then we're going to pull an AP Stat students. What's the parameter? Well, we're talking about mu, which is the true mean AP score at East Kentwood. And the statistic that they found was X bar equals 3.8. X bar sample, mu population. Yes. Okay. Mu population, X bar sample. Okay. Difference between parameter and statistic. Parameter is population, sample is statistic. Good. PPSS. That's how you remember that. Okay. The rival high school had a mean of 3.11 last year. Boo. There are two possible explanations for why the sample mean from East Kentwood is greater than 3.11. They lied. They cheated. So the rival high school claims that East Kentwood mean AP score is less than 3.11. Less than 3.11. Oh, okay. My bad. Then East Kentwood claims that East Kentwood mean AP score is greater than 3.11. Which one is the null hypothesis? Yep. Null hypothesis. What is that? Well, like, what is that? That's null hype. Yes. I'm gonna create my own font. Stop. No, see, like, I don't even know, man. All right, this one is called the alternative hypothesis. I know, crazy. What? I've done that before. Okay, so the HO is 3.11. The alternative is that the mu is greater than 3.11. Remember, for your null, it's got to equal a certain number. So mu is going to be equal 3.11. Okay? So if it's not greater than, then it fits the null. Yeah. What? That didn't even sharpen the pencil. Not even close. Nope. Liar. I didn't know that was a thing until now. All right, to test East Kentwood's claim, we're going to assume, number one, the true mean for East Kentwood is 3.11, and then find the probability that a sample of 10 students would give an X bar of 3.8 purely by chance. Take a random sample of the 10 students from a population that has a mean of 3.11. So flip to the next page. Because I gave you the sample scores. All right. Now is the opportunity to take a sample. I hope so. This is going to be rough. Okay. So you are going to take a random sample. So what you need to do is on your little document, it's got 1 to 253. You've got to use a random number generator 10 times without repeat numbers. Yeah. The alternative is greater than 3.11. Yep. Okay. So go ahead and take a moment. Take 2 samples. No, you got to add. Okay. So you actually didn't do terrible. So we're moving up in the world. Maybe I can trust you next time. All right. Go ahead and copy down the dot plot. Go ahead and copy down the dot plot. What?
You're like addicted.
Excuse me? All right, this is called a sampling distribution of X bar. Sampling distribution of X bar. You have to, if you do a dot plot on your FRQ, which they're probably gonna make you do at least one, you got to label. Like, what is this talking about? It's a sample. It's talking about the distribution, and we're talking about X bar. And then looking at the bottom, the sample mean of the AP score. So, like, what thing are we talking about? So, what does each dot represent?
One sample of 10 AP, the average of
Okay. One random sample of 10 students and the mean calculated from that sample. I'm just going to say mean calculated. All right, for number 6, for a school with a mean AP score of 3.11, what is the probability that a sample of 10 students gives a X bar value of 3.8 or greater based on our dot plot? So 3.8 or greater, how many we got? 1 out of how many dots we got? 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 1 out of 28, which is that's so, it is true. It's like 3.6. Okay. So you got a p-value of 0.0357. I mean, we could round that to 0.036. It's fine. Yeah. What's up? Who would you have dinner with, dead or alive? Alicia. Who would you have dinner with, dead or alive? I mean, like, the like what person? Oh, me. Yes. Good answer. Okay. Listen, I would be the best dinner person. We would go to Provino's. All right. So here is your p value. Okay, just a reminder for your mu. That's mu sub x is still the same thing as your mu. For your standard deviation, we've got sigma divided by the square root of n. Stop it. Based on your answer to question 6, does East Kenwood's observed result of X bar equals 3.8 give convincing evidence that they have a mean AP score greater than 3.11?
He denied.
Why? Okay. So we reject the null, which means what? We have convincing evidence of what? Okay. So yes, we have convincing evidence.
That this, like this value, like 8.
Okay, so it's highly unlikely for East Kentwood to get an X bar of 3.8 if the true mean is 3.11. So it's kind of like, I feel like AP Stats is very much like a gossipy kind of thing. Because, like, think about it this way. It's like, if Patricia said this about Ryan, then Ryan didn't do it. You know, like, it's very gossipy.
If you put it that way.
Yes, like, think about it. It's highly unlikely that East Kentwood is going to get a mean of 3.8 if the true mean is actually like 3.11.
Oh my God, yeah.
Exactly. Exactly. So like when you read this kind of stuff, like AP Stats is like just math gossip. Yeah. You're welcome. Now I just made it all interesting. It's fine. No? Autumn amused. Put this in gossip terms. Do you have convincing evidence or not?
Like, did you?
Okay. Where are the receipts? Yep, where are the receipts? All right, flip the page. Let's go. Flip the page. Flip the page. Flip the page. Yep. All right. So, man, this one has way too much time on her hands. All right. So, let's summarize so that we can practice and we can move on. Okay. All right. So we talked about hypotheses. Okay, where mu is the true mean in context. We talked about the null hypothesis. What? I can delete. Thank you. Okay. So let's try this again. Let's do pink. All right, so we got hypothesis. Okay, and we talked about mu being the true mean, not the fake mean, the true mean. Okay, we talked about the null and how HO is going to be whatever value. Okay, we talked about the alternatives. Okay, so that means that mu is either less than the null or mu is greater than null or mu does not equal the null. I do want to point out that this one is one-sided. This one is 2. So remember, like two-tailed tests and that kind of stuff. That's where this comes in. If they don't stop messaging the group chat. Exactly. Do what? Hold
Are
on.
you not allowed to hit this?
So I hate everyone. All right. Interpret the p-value. No, I've never been one to like be in a group chat. So, assuming the null is true, there is a p-value. Yeah. Probability of getting X bar of whatever it is or more extreme. When we put more extreme, that means less than or greater than, depending on the scenario. Everybody get that? Okay, so when we say more extreme, it's either one or the other. Purely by chance. Now, when we talk about conclusions, we've already talked about this. Okay, if the p-value is less than your alpha, what do? We reject that null, right? Okay, and then we do have convincing evidence. If we fail to reject the null, then we do not have convincing evidence. Alpha is normally 0.05 unless stated otherwise. If it's less than, we reject it. Yeah. Do you remember our little saying? If he doesn't have enough money, we reject. Right. Yes. Okay. Then take a moment. Go ahead and do. Okay. So the AP Stats teacher from East Kentwood wondered if AP exam scores from the previous year were better than the scores from the rival high school. Boo. To the north. Mean of 3.11. She took a random sample of 10 of her students from last year and found a mean of AP score of 3.8 with standard deviation of 0.84. State the appropriate hypothesis for performing a significance test. Be sure to define the parameter of interest. What is the null? I can't draw mu. 3.11. And the alternative is that it's greater than 3.11, right? I know. Because she said better than the scores, right? I think I'm done. All right, so mu, let's try this again. Mu is the true mean of the AP score for all of East Kentwood's students. Do the results provide some evidence for an alternative? Explain. Why? Because Becky is greater than 3. That is not true. So your X bar is 3.8, right? Oh, I'm sorry. I need a nap. 3.8 is greater than 3.11. Yeah, it is. Yes, it is.
Okay.
Yeah, it took me a second too. It's okay. All right. So 3.8 is greater than 3.11. So we do have some evidence. We have some receipts. I'm just gonna buy into this whole gossip thing. It's gonna be great.
Explain it that way.
Maybe. I'm gonna turn this into like a big episode of Gossip Girl.
Don't even know.
Okay, the teacher performed the significance test and obtained a p-value of 0.014. I'm reading. Okay, so assuming the null is true, so we're assuming that Becky is true, right? Then there is a 0.014 probability of getting an X bar of 3.8 or greater purely by chance. I feel like I read this sentence and like all I can think is a girl that was like, as if, like that's how I feel. Assuming that the null is true, there's a 0.014 probability of getting X bar of 3.8 or greater purely by chance. Yeah, right? Like this is literally what AP Stats is. Outlandish. All right, so at an alpha of 0.05 level, do the results provide convincing evidence that the mean AP score for East Kentwood is greater than 3.11? So because 0.014, I'm gonna fight y'all. Y'all writing this down?
Yeah.
Do we reject or fail to reject? We reject, right, Andy? We reject the null because 0.014 is less than 0.05. Yeah? This is just talking about like finding the p-value and just making a conclusion based off of that. We haven't done anything crazy yet. Yeah. This is almost like just a review at this point, right? Like we've talked about all of this. Yeah. Okay. Now we do have convincing evidence, right? So we have convincing evidence that the mean, this is getting progressively worse, that the mean AP, nope, 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 we don't like that. No. We have convincing evidence that the mean AP score for East Kentwood is greater than 3.11. So y'all give dogs accents like they talk. Like dogs talk, right? Yes? Lame. Benjamin has an English accent. It's really great. So. Yeah. So they told us in the previous problem, right here. You see it? Ah!
I'm not gonna do it.
Yeah. Mm. Okay, watch. So 3.80, 3.11. 80 is bigger than 11, right? Yeah, I feel you. That's how my mind was too. All right, we good? Flip the page.
Oh, yeah.
Did you flip the page? Hurry up. Flip the page. Bum, 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 bum. Do y'all actually use the videos?
No.
Okay. Fine. I guess I'll keep them.
Yeah.
Mhm.
Yeah.
Okay. Okay. All right. What is normal body temperature?
It's 97.
Yeah.
Well, that's a 98.
90%.
It is 98.6. What is it in Celsius?
Great question.
That's what, like.
I think it's like 36. Go ahead.
Did you know that? Like past like centuries, the normal body temperature has been like lowering slightly by like a bit.
Because climate change. Because what you do is it gets hotter, right? So you sweat more. So you lower your body temperature. Yep. Okay. So for many years, doctors have told people that normal body temperature is 98.6. But today, we're going to find out if this is true. Record your body temperature at the front of the room. Think of the class as a simple random sample of all high school students and then use to find this. So I'm not going to take your temperature. And the reason why is because I feel like that's invasive just a little bit. Because, like, you know, what if you have 100-degree fever? That's on you, right? Okay. So let's just say, ayo, ayo, ayo. Let's say we have 98.237. Let's say that the standard deviation is 0.822 and our sample is 32, y'all. Okay, again, I would go around, I would take all your temperatures, I would add them up, divide by how many there are, and then I would find the standard deviation. How do we find the standard deviation? Use your calculator. Okay, cool, good answer. Because otherwise it takes forever. Is there convincing statistical evidence that the mean normal body temperature is different than the doctor's claim? Use an alpha of 0.05. Normally they'll tell you the alpha, but sometimes they don't. Assume 0.05 until proven otherwise. So we're going to do a one sample t-test. Nova, this was your question for the mu. Your alpha is 0.05. Your statistic, we already found, is X bar 98.237. Your parameter is the true mean body temp for all high schoolers. No. Okay, when you're doing this type of stuff, this is like an FRQ. Again, you are already assuming that the reader is not the smartest person, right? So you're having to literally explain everything. All these little parts are points. Yes? Okay. God bless. All right. Hypothesis. Our null is that our mu is going to be 98.6. Our alternative is that mu does not equal 98.6. I know, crazy. Convincing evidence for the alternative, we got X bar equals 98.237, which does not equal 98.6.
Like, in the effort to do like that in my very shoes,
Portion, yes.
like,
Exactly. More t-shirts. Yes. No, Spencer? Yeah. There is a part to the AP exam that's digital now. I think it's just the multiple choice, but I got to go back and make sure that that's a true statement. When? May 8th at 8 a.m. No. I think I have to administer, not that exam, but.
May?
Uh-huh. Uh-huh.
It's like.
Uh-huh. All right. It's okay. Next Lion time, next semester, you're going to be with me like all the time if you're taking the AP. Gonna be great. No, it's fine. All right. For random, we've got a simple random sample of all high school students. Okay. 10% condition. We have 32, which is less than or equal to 10% of all the high schoolers ever in America. Okay. Can we generalize to the population, or are we showing causation? Generalize why? Okay. And
Like the question is about, is the temperature this, not is there a link between like high schoolers having a higher body temperature compared to someone else?
all right, Caitlin.
Because random.
Okay, random assignment is causation. Random sample, generalized to the population. Know the difference. Okay, and then the last one is normal or large counts. 32 is bigger than or equal to 30, which is following that CLT. Remember, 30 came from some old dude who figured out that 30 was a magical number. This semester. I get one next semester. I wish they would have given me two. I wish I would have two of these and then one of the AFA, but it's okay. Because then I could like perfect things. But I get like one opportunity to do this right. All right. The general, specific, and plug-in numbers, all this stuff. All right. The general is going to be the test statistic is equal to the statistic minus the parameter over the standard. We're going to say error. Remember, standard error and standard deviation are the same but different, but still same. What's the difference? What? Sort of.
Population example.
Population and sample. Okay. So the specific formula is T equals X bar minus the mu divided by the standard deviation. I'm sorry. Yeah. Standard deviation divided by square root of N. Okay. We're going to plug in the numbers. All right. We're plugging in the numbers. So we get 98.237 minus 98.6 divided by 0.822 divided by the square root of 32. No. I was a dancer and I played the violin. I don't sing. So my little sister does the singing. Yeah, she is the reigning Miss Henry County, and the reigning Miss Cumming Fair. And then she's going in January to the Fairest of them All pageant. And then she's going to Miss Georgia in June. Yeah. Yeah. So you might know a celebrity, it's fine. Yeah. What? That 98.237 doesn't equal 98.6. Yep. All right. So when we draw our little picture, you're going to draw a curve. You're going to put that the mu is 98.6. You're going to put that down here is 98.237. Okay. And that over here, we've got 98.963. Why did I shade that part in? Okay. Say again? No. All right. The test statistic is T equals negative 2.50. How do we get our p-value? Okay, so you could do either. Okay, so go ahead and confirm that you can find that. Yeah. Yeah. There you go. Yeah. So so hey, how do you find the p-value on your calculator? So how do you find the p-value on your calculator?
You could go to that one. Yeah. No, it's amazing. It's.
Your stunned silence is very reassuring.
It's like it's
All right, ready? Menu, statistics. That test.
Huh?
That test. And then t-test. Okay? You're going to enter the stats into that, where your mu is 98.6. Your X bar is 98.237. Your standard deviation is 0.822. Your N is 32. Ta-da! Your p-value is 0.018. No. All right, for those of you who are visual learners, give me 2 seconds. I'm gonna put that on the how to find calculator. Yeah. Or not. What? That's the mean. That's what your normal body temperature is.
So what's X bar? Is that X bar?
X bar is what we found. The mean of this classroom.
You got mine.
Yes. What, Bruno? What? Oh,
You feel weird, bro.
y'all are all being weird. Okay, so running that back really quick. All right, so we're running it back. We're on chapter 11. And we said go to menu, go to stats. What's up? Then go to stat test, and then go to t-test, right? And then you're gonna hit statistics, and then fill in data, right? Okay, so conclusion, make a conclusion in the context of the problem. Assuming that the null is true, I'm just gonna do this in a text box. Assuming is true, M equals 98.6. There is a 0.018 probability of getting an X bar of 98.237 or lower, or 98.963 or greater, purely by chance, because 0.018 is lower than 0.05. We reject the null, and we do have convincing evidence that the mean body temperature is different than Doc's claim. What? Say it again. Remember, it's on either side.
So this time we don't have to multiply it by two?
Nope.
Why?
So remember that our null is that it's 98.6. Our alternative is that it's anything else, right? We found that it was 98.237 from our data. So the likelihood of that happening, as well as the other side of the graph happening, that should help us with figuring out if that's the true mean. Yeah?
Yeah.
When we standardize this though,
Not multiply it.
Nope.
Why?
Why?
because it didn't ask
Well,
for,
if you're doing both sides.
okay, so if you wanted to do this only in the calculator, you can multiply it by 2 then. Watch. Y'all gotta stop talking. Okay. Or continue talking, like one of the two. It's fine. You could go to TCDF. And do you remember how we did like the lower bound being like negative 9,999? The upper bound is negative 2.50, which is what we found earlier. Okay. And then our degrees of freedom would be 31. When you plug that into your calculator and then you multiply it by 2, that would have given your p-value of 0.018. So you could do it this way. That's where that multiplying by 2 comes in.
So on the, so
Go ahead.
if the right one's had a two for both sides, I can say instead of minute for like minute is blah 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 or and blah blah blah. Not like two separate ones. Well,
It could be both. Or is one of the other
yeah.
combined. It's like, or you remember how like addition is or and is multiplication? Yeah. Okay. Yep. What is the test statistic? T equals negative 2.50.
So you round it to a small negative 2.49.
Yeah, negative 2.50. Round it. If we were to construct a 95% confidence interval, would the interval contain 98.6? Did we reject the null or did we not reject the null? So, no, it wouldn't contain 98.6 because the significance test that we just did rejected the null. And so 98.6 is not plausible. Okay, another class did the same body temperature activity with the following result. Use the t on the calculator to find p-value. What was your p-value here? Yep. All right. Are we going to reject the null? So is 0.023 less than 0.1? Yes. Is 0.023 less than 0.05? Is 0.023, so no.
Oh.
On the next one, you're going to find the t interval on the calculator. How do you do that? Yeah, where is it located? Go to stat, go to distributions, then what? Mm-hmm.
It says confidence interval.
Mm-hmm.
Then here, it's 6, confidence interval equals 6, and then 2, t interval.
Yep. And that's where you're going to enter your X bar. You're going to enter standard deviation. You're going to enter your in and then your confidence level. As you change the confidence level, your interval is going to change. So when you do this, you should have gotten 97.04, 97.404, 98.396. We are going to reject the null. On the next one, 95%, that's going to be from 97.303 to 98.497. And we're going to reject the null. And then the last one is going to be 97.095 to 98.605. Yep. So you go to menu, you go to stats, so go to menu, go to stats, go to dish, it should be confidence interval. Okay, so confidence interval, and then P interval. Plus. Yep. Right? What connection did you notice between the answers in 1 and 2? So the decision on whether or not to reject the null is the same using significance test or a confidence interval. So again, the decision of whether or not to reject the null is the same using a significance test or a confidence interval. And this must be two-sided. If it's one-sided, you can't do that.